Okay, everyone, welcome to my channel. My name is Ryan. Thanks for showing up today. So, in the narrative, I want to talk about brute force analysis versus hierarchical clustering with early termination and look at the difference between the time to compute the solution and the actual solution that is derived, right? So, the brute force is basically a naive single linkage that's recomputed all the intercluster distances and everything has to merge. So this is like doing the same thing over and over and over and over and over and over and over ad nauseum, right? Including the annoyingness. Ad nauseum means doing the same thing to the point of being annoying, including the annoyingness until you finally arrive at a solution. Now, hierarchical clustering with early termination, basically, you stop merging as soon as the next linkage distance exceeds a correlation threshold. So this is implemented efficiently with a union find pass over pairwise distances that is less than the threshold. So we'll see an example of that. I know it sounds a little bit weird, it gets a little bit complicated, but brute force method looks at every single possible combination. And if you know the difference between a combination and a permutation, I learned this recently, like I studied this in school, but it didn't really resonate strongly with me until just very recently. The difference between a permutation and a combination is that the permutation considers the order of items while a combination does not. So if you look at all the possible combinations, it's every single iteration of every single thing, right? A permutation looks at the order. So 1 has to come before 2, 2 comes before 3, and 3 comes before 4. So if you think about it, like if you have a lock on your bike, if you have a bike lock or a lock on your scooter or whatever, if you have some kind of lock, it's always called a combination lock, but that doesn't totally make sense. It's really should be called a permutation lock because the permutation is defined as the order matters. The combination looks at every possible iteration of everything. The combination is the order does not matter. Does that make sense, right? Combination lock is kind of misnamed, and I don't know who came up with that idea, right? But the combination lock is not a combination lock, it's a permutation lock because the order matters. But the combination, you're looking at brute force combination, you're looking at every single possible ordering or combination of everything. And hierarchical clustering looks at the place where it doesn't make sense to continue on to do more calculations and just stop. So hierarchical clustering is a very efficient way to do some type of analysis, and the brute force method is just going to take more and more and more time because you're constantly calculating, and the cost is the computer calculation time, energy or time or whatever, right? So more and more calculations are not necessarily better if you arrive at a decision or an optimization point, and that's the best you can get. Just stop there, right? There's no point in going on, right? So that's what we're looking at in the narrative today. So the brute force method versus hierarchical, we are going to run this script right here. I'll give you all the codes so you don't have to recreate this or try to learn it or try to memorize all these things. I'm importing historical time series data from the web and looking at the correlations between different stocks, right? So here is the stock list. If you look at this right here, we have SPY, which is the S&P 500. We have QQQ, this is an index. We have a couple different stocks, XLC. I think this is an energy company. And then I just have some regular stocks over here. So we're going to look at the correlations of these different stocks and see which ones are highly paired together and which ones are correlated together. So these right here, TLT, EF, SHY, LQD, are all pretty highly correlated because they're all linked together. And this network graph, like I have a lot of videos on my channel about network graphing, these are all pretty similar to the terms of being greater than 65% correlation. Okay, if you look over here, 0.65. So if the deviation or the correlation is greater than 0.65, these are grouped together. So this goes into the same network. This is called network graph. This DBC is off by itself. This is gold. So gold tends to perform very different from a lot of assets. Gold is a great place to be during the 2008 financial crisis, during the COVID crisis, gold was fantastic, right? It was blowing up. It was making a lot of money because people get scared during a crisis. They go to gold. Gold is safe, and the price of gold shoots up maybe 100%, 200%, maybe 400 or 500%. Right? It goes up a lot during times of crisis. You run for cover, right? Go to cover. Go to gold in times of crisis. When there's not a crisis, gold does not perform very well. And but over time, it tends to, I think, at least beat inflation, but tends to do its own thing, right? So you can see the performance over here. This is different from DBC. I would have to look up DBC. I'm not even sure what that is. I have to look this up. Let me see. Finance. I just picked these randomly. DBC is what? DBC. It's not Deutsche Bank. I know that. Invesco Commodity Index Tracking Fund. Okay. So these are commodities. And let me just look at the year-to-date performance. Up 3%. Yeah, not huge, right? But that does perform by itself. Well, 5 years up 62%. All-time is down 10%. Okay. Okay, so this thing is kind of like a random outlier. So this is commodities, this is gold, and these four tend to have high correlation, greater than 65%, and these tend to have high correlation too. And this network graph confirms all the networks and the relationships between all these different stocks, right? So I like this. This is called Plotly Viz or something like that. What is the name of this thing? Let me go back over here and see this. I've used this in a couple of videos. Okay, stop it. Stop skipping over here. PyViz. This is PyViz. So this is Python Visual Library. Very dynamic, very interactive, very creative. I like the way that this thing performs, and you can see all the relationships between these different stocks, and you can see that they're all pretty highly correlated, about 65% to get the cutoff here, right? Otherwise, they would go into these other groups over here. So you have LQD, SHY, TLT, IEF. Similar, gold is doing its own thing over here, and commodities are doing its own thing. And all these other stocks over here are pretty much highly correlated, and they all have relationships with themselves up to 65%. Now, if you change the threshold or the cutoff over here, 0.5, we'll have like a different representation here. So I'm gonna guess that there's gonna be more that are correlated and more or more like co-joined together. Let me see here. So gold DBC. Oh, it still doesn't do it. We have kind of the same thing we saw before. If I do go down to 0.25, if I cut that in half and go to 0.25, let's recalculate that and see what that looks like. I'm guessing that there's gonna be more consolidation, I think. Still not. Wow, they're so kind of different. This is the first time I'm seeing this. So kind of different in the way that these things perform. Was there another threshold? Oh yeah, that actually was two. Okay. So 0.25. So I have to change both of these. So hang on for a second. Let's see what the outcome is here. Let's see if more of these are joined together. And it's recalculating right now. Let me see what this is. I think that was that. Oh, there's a couple more cutoffs. Okay, growth threshold 0.65. Yeah, but you can see they're kind of joined together here, right? When we kind of like merge these together with a lesser threshold. So it's a little bit arbitrary what you think is the right threshold here to set this. I can do 0.25, and these are probably going to be merged together. Recalculate, but not necessarily. And then if you want more dispersion or more Yeah, there it is. So everything is kind of co-joined together because all it has to do is just have a small 0.25 correlation, and all these things are linked. But if you bump that up to let me see, 0.85 you're going to see more dispersion and more separation between these different entities, right? 0.25, 0.25. You're going to see more discontinuity between these because now the threshold for doing this correlation analysis is greater at this point, okay? So you can see more dispersion. Okay, so these two, that's exactly what I would expect. So these two are off by itself. Gold, that does its own thing. These do its own thing. These are still pretty highly correlated over here. And this is energy. XLE is energy. Shy is off by itself now. And these are by itself too, okay? And you can see if you look closely, the threshold here is 0.13 or 13, right? The darker the line, the greater the threshold. This is going to be pretty small. This is 1, right? This has a threshold of 1. This has 7. This one's going to be pretty small over here. This has 3. This has a threshold of 1. And these are darker and they're more like intense, right? So this has a threshold of 8. So anything beyond that threshold is going to get kicked into a new bucket or go into a new group. Anything less than that, it's going to go into its own homogeneous group, right? So everything in red with a red line here is homogeneous. Everything else is heterogeneous, so that's different. So these are all hetero, right? These are hetero over here. These are homogeneous. This one's hetero, and all these over here are homogeneous. So I like it how with these high-vis graphs and Plotly, you can zoom in, you can zoom out. It's very interactive. You can see all the details behind it, right? Very, very nice way of representing the data. And everything is dynamic and very interactive here. So the last thing I wanted to show you was as you do these kind of brute force methods versus hierarchical clustering, and there's another way to do this too. It's called heuristics. You can do a heuristic analysis. A heuristic is when you do a very close approximation of your analysis, but it might be off just a little tiny bit, maybe 1%, maybe 0.5%, maybe 2% deviation from the actual like true number. But if it runs 100,000 times faster, you might want to consider using heuristic just to get the answer, to get the solution, to get this done, get that out the door, get this in front of key stakeholders, get this in front of your boss, and just get it done. I'm a big fan of just doing what you need to do and getting done with it rather than spending weeks or months or who knows how long, like 8, 9, 10 months, maybe a year to do your analysis. Like, I don't want to wait a year. I want to get this done in 5 minutes, right? And get it out the door, get it over the line to score a touchdown, get this done, right? So the brute force method will guarantee you a solution. It's going to be very, very, very accurate. But sometimes you just need to do hierarchical clustering or heuristic analysis and get it done. And look at the difference here. The time to finish this took about, it's a little bit hard to see, can't see this number right here. It's so small. 0.001 seconds, right? So a fraction of a second to do this analysis took 0.17 seconds, right? So 0.17 seconds is not a lot, guys. That's a small thing. But if you have to do this analysis over and over and over and over, or this is a pretty small analysis, this is pretty straightforward, pretty simplified. If you had to do a very complex analysis and it's going to take days or weeks or months, you might want to consider hierarchical clustering with early termination or some kind of heuristic where you can get the analysis done. It's very fast, very efficient, very accurate, but it might not be 100% accurate, might not be 100% guaranteed to be statistically accurate. But if you can get very close to a solution and you're done in, I don't know, an hour, a couple hours, one day, your analysis is done, I would say just take that path of least resistance and do that. Get that on your boss's desk, do a nice PowerPoint deck, get that in front of your key stakeholders, and you are done. And that's fantastic, right? You're done with your work. You can go relax, you can go enjoy. And it's mission accomplished. Like, you've done what you need to do. Everybody's happy, right? Do that. If you do the brute force method and you do the permutation or the combination, remember the permutation and combination kind of like a mismatch of names. Permutation is a certain order of events. A combination is every possible combination of events, right? So you have a combination lock. It's misnamed. I don't know who came up with that idea. It's the wrong name for that thing. It's really a permutation lock. So if you want to do that, you can go do that. I don't know what the outcome is going to be. I don't know what the recourse is going to be. That's up to you, right? You and your boss are going to decide that. Your stakeholders are going to decide that. I'm saying if you consider a hierarchical clustering with early termination solution, right, that's going to be very close to the approximate solution or heuristic solution. You're probably better off with that. Less stress, less effort, much faster time to delivery, and you are done. DONE done, and you are kicking back and relaxed for the rest of the day. I would say go with that. That's just a better outcome, right? Just better outcome, guys. No matter what, no matter how you slice it, that is going to win every time. So anyways, I'm going to save this notebook. I will deliver the notebook when I drop the video. I'm going to drop it a little bit later today. You'll have all the code samples that I showcased right here. You'll have everything you need. You can copy and paste it, run it in your own environment, and I think you're good to go. Okay, if you have questions, let me know. Post it in the comment section. If you like this video, post it in the comments. Please subscribe. Please like the video. And that's it, guys. I think I proved the point. I think I illustrated what's going on here. And I would say mission accomplished. Thank you for everything. Thanks for your time today. I'm going to wrap it up right here, right now. And I will see you in the next video, which I'm going to post pretty soon. Thanks, and talk to you soon. Bye.